For 2.5 million years, the Earth's climate has fluctuated, cycling from ice ages to warmer periods. But in the last century, the planet's temperature has risen unusually fast. Scientists believe it's human activity that's driving the temperatures up a process known as global warming. With global warming threatening food security, conventional farming methods fail to provide stable growing conditions, affecting crop quality and yield, which consequently raise food concerns.
Greetings, my name is Richard Jr. Alnavo and my science investigatory project is Hydrozen, UV-resistant greenhouse for regulating temperature and cultivating hydroponic systems. Greenhouses has existed since Roman times. Through modernization, scientists have made innovations to give us the horticultural structure we have now, designed to create a controlled environment for growing plants. However, according to a research by Susie in 2022, traditional greenhouse designs rely on energy-intensive cooling systems. They also oftentimes struggle with excessive heat buildup, leading to temperature fluctuations dangerous for plants. I came up with a solution for this issue. With the use of UV-resistant additive solutions, we can create a greenhouse that can withstand prolonged exposure to sunlight and act as an effective insulator against UV rays and heat to regulate optimal temperature for plant growth. I also opted to utilize hydroponic systems for their potential to revolutionize food production by offering water conservation and space optimization. This is classified as sustainable agriculture. As opined by Fiveable in 2025, sustainable agriculture is a farming method that aims to fulfill the current food and fiber demands of society without negatively affecting future generations' ability to fulfill their own needs, thus creating hydrogen. The following are the research questions that we need to answer. Number 1. What impact does UV-resistant polyester have on the growth conditions and protection against extreme heats to plants within greenhouses? Number 2. Can the greenhouse provide the required environment for cultivating the hydroponic setup? Number 3. Is the hydrogen able to promote sustainable farming within the agricultural sector? The plants that are going to be used for this study are green leaf lettuce and red leaf lettuce, for their versatility and their ability to thrive in hydroponic systems with ease. I prepared two setups, one experimental and one controlled. Each setup will consist of one green leaf lettuce and one red leaf lettuce, both after germination. The experimental setup will experience the hydrogen cultivation, and the control setup will be following traditional farming methods. Within the hydroponic setup, I used coco peat as the aggregate substrate, providing stability for the plants and serving as an additional nutrient source. To maintain the water's pH level within the optimal range of 5.5 to 6 for lettuce growth, I use Prima Plus fertilizer solution. Here is my blueprint of hydrogen. There will be separate preparations for the greenhouse and hydroponic system in order to develop hydrogen. On the screen is the list of what I used to create the prototype. To construct the greenhouse, a wooden board measuring 1 meter by 1 meter was used and cut into an 18-inch by 36-inch panel. Additionally, 5 1-meter wooden pole was sectioned into 4 12-inch pieces for the base of the walls and 4 8-inch pieces for the roof. To provide structural support and connect these components, 4 30-inch wooden panels and 2 8.5-inch wooden pieces were used. Once the framework was assembled, the entire structure was covered with a polyester plastic film to complete the greenhouse. The data gathered from the experiment were tabulated. The overall mean of the plant growth in the experimental group was 2.09 cm for red leaf lettuce and 2.1 cm for green leaf lettuce, which is highly acceptable in terms of the usual growth mean of 1.45 cm for a healthy lettuce. This suggests that hydrogen cultivation promotes faster plant growth. The overall mean of the plant growth in the control group was 0.43 cm for red leaf lettuce and 0.5 for green leaf lettuce, which indicates that the plants experience stunt-in growth culturing within conventional irrigation methods. The t-test output confirms that the difference in the means is statistically significant. In conclusion, the research successfully achieved its main objectives. Hydrogen aligns well with sustainable agriculture by reducing water consumption by up to 90% and avoiding the utilization of energy-intensive materials, and at the same time enhancing crop yield and quality while protecting plants from the adverse effects of global warming.
Are our three biggest recommendations for future researchers who want to enhance this study. And that will be all. Thank you.